Okay, so unfortunately, Mandalina Vlaseanu couldn't be here, but she will be at the round table. So you can keep your questions to directly to her then, I guess. So she did her PhD at Princeton. She has a sort of a psychology and economics background, and is currently starting at NYU. Yeah, I guess let's watch the video, and you can keep your questions, and hopefully we can bring them into the panel discussion.
Hi, thank you for coming to my talk. I am Mandalina Vlaseanu. I'm an NYU postdoctoral fellow and incoming assistant professor of psychology. And before NYU, I obtained my PhD in psychology and neuroscience from Princeton University, where I studied collective phenomena emerging from sociocognitive processes. And this work was mostly motivated by events happening in 2016, when large-scale targeted misinformation campaigns started taking over the world with critical consequences. Over in the UK, citizens were led to believe that the British economy would benefit from leaving the European Union. And in accordance with this belief, they voted in the 2016 Brexit referendum, a decision that a majority of voters then regretted when faced with the actual consequences of Brexit. In that same year, in the United States, another such misinformation campaign led people to believe a vast amount of false information, which was a critical component in the 2016 presidential election. And these examples are not isolated incidents. People's susceptibility to holding false beliefs spans topics and is consistent over time. For example, a third of Americans believe global warming is a conspiracy, and a third of American parents believe vaccines cause autism. And holding false beliefs can have dire consequences, as false beliefs have been associated with increased climate change denial, decreased vaccination rates, and increased intergroup prejudice. Therefore, in my work, I'm interested in understanding how we can change false beliefs in vulnerable communities. But first, what are beliefs and how do beliefs change? In my work, I operationalize beliefs as the mental acceptance of the truth of a statement. And note that beliefs differ from knowledge in the conviction with which they are held and in the self-referential element they embed. Beliefs are also different from attitudes by focusing on the true-false dimension rather than on the good-bad dimension. And normative models of belief change have proposed that beliefs change on the basis of new evidence. And indeed, many information campaigns rely on a rational model of belief update. In my work, I adopt a sociocognitive framework to study belief change that complements this classic view by showing how superficial features of the belief evaluation experience can also impact beliefs, and showing how these features can be leveraged to change false beliefs in interventions. But investigating beliefs only at the individual level would miss essential processes that occur when people interact, giving rise to emergent collective phenomena. Indeed, recent research has shown that communities of individuals are characterized by shared attention, collective memory, collective emotions, collective actions. And understanding these collective processes involves uncovering the sociocognitive processes that lead to their emergence. And to visualize the basic principle behind this idea, imagine a social network of interconnected people. If we pick a cognitive process and, for example, upregulate it in an intervention, the social network might become polarized on a given issue. On the other hand, if instead we downregulate that same process at the individual level, the collective outcome can look very different in an unexpected way. So in this presentation, I'll show how these often asymmetric dynamics occur in collective beliefs. And I'll also propose a framework for investigating future such emergent phenomena. This framework relies on first identifying individual level cognitive effects, such as various mechanisms of belief change. The framework then suggests exploring individual effects in dyads of interacting individuals to observe their manifestation in a social context. And finally, the framework recommends investigating effects in communities to understand how they propagate through social networks. Here, I'll apply this framework to study collective beliefs, and specifically, I ask how the micro-level cognitive process of changing a belief can trigger macro-level collective belief change. The first individual mechanism of belief change I'll present here leverages mnemonic accessibility. And this study builds on the literature characterizing memory as constructive and malleable. In this work, memory had been found to impact beliefs through a process called the illusory truth effect, which refers to the increase in belief endorsement for familiar information. In other words, an upregulation of memory has been shown to lead to an increase in belief endorsement. And given this finding, our question was whether a downregulation of memory would decrease belief endorsement. To investigate, participants were asked to rate the accuracy of a set of 24 health statements organized across categories. And then participants listened to another person mentioning a selected subset of these initial statements in only some of the initial categories. And this manipulation had been shown to upregulate the memory for the practiced information while downregulating the memory for the related but not practiced information compared to unrelated information. Participants were then asked to recall the initial statements in an incidental cube recall task, and finally to evaluate the initial statements again at post-test. The typical convention for labeling the items in this paradigm is that the practiced items can be labeled as RP+, the within category not practiced items are RP-, and the outside of category are NRP, or no retrieval practice items. So here I'll plot these 3 item types on the x-axis, and on the y-axis I'll plot belief change from pre-test to post-test. And in 2 samples of Princeton students, we find that the practiced items, here in red, became more believable, and the unpracticed items, here in blue, became less believable than the unrelated items, here in green. Therefore, downregulating memory resulted in a decrease in believability. However, these effects only held for initially moderately endorsed beliefs, so not for extremely endorsed or extremely opposed beliefs. The take of this study is that to decrease a moderate belief strength, one strategy could be creating the context to discuss related information. Also, at the individual level, we assessed how different ways of presenting evidence can lead to different levels of belief change. So in this study, we draw from research on the associative learning theory introduced in 1972, suggesting that while predictions that are confirmed consolidate knowledge, predictions that are violated, or prediction errors, are used as cues to adjust future predictions accordingly. And this adjustment is proportional to the difference between the prediction and new information acquired. And this law of update had been shown to apply to perception, memory, learning, cognitive control, decision-making, and other cognitive functions. In the study, we're investigating whether this law holds for beliefs. So first, participants rated the accuracy of a set of 36 general knowledge statements. And were then assigned to one of 2 conditions, control or prediction. In the control condition, participants were given a set of statistical facts that served as evidence. Whereas in the prediction condition, participants were asked to predict each statistical fact and were then given the correct answer on a scale. And the distance between participants' prediction and the correct answer was computed as the size of the prediction error. Lastly, participants were asked to rate the accuracy of the initial statements again. We recruited a main sample of 704 in a replication of a nationally representative sample of 1,073 cloud research workers. And the results plotted here as the prediction error size against belief change show a linear relationship between the size of the error participants made and the degree to which they changed their beliefs as a result. Moreover, we find that it's when participants make the largest errors that they update their beliefs more than in the control condition. We also find that these effects hold across political ideologies, in our case, US as Democrats and Republicans, and regardless of belief type, Democratic, Republican, or neutral. This finding suggests that an effective strategy of changing beliefs can be the dissemination of surprising evidence in a prediction and feedback format, which will trigger large prediction errors and lead to rational belief updating. Finally, at the individual level, we wondered how social norms can be used to change beliefs. And here we build on the vast literature on the impact of social norms in people's lives. For instance, theoretical work on social consensus proposes that a large group of people believing a piece of information acts as a secondary reality test, making that piece of information more likely to be believed. Moreover, empirical work shows that information that appears as normative, for example, if a tweet has a lot of likes, is rated as more believable than information that appears as non-normative. Here I'm interested in whether this effect can be used to change a belief. So to investigate, participants first rated the accuracy of a set of 32 health statements, after which they were exposed to a set of tweets serving as evidence, either in favor or against these initial statements. And while half of the tweets were designed to have a large number of likes in the normative condition, the other half had only a small number of likes in the non-normative condition. So here's an example of a tweet we created for the non-normative condition. Lastly, participants rated the statements again at post-test. And in a sample of 200 Princeton students, I found that statements followed by normative evidence, here in red, changed more in line with the evidence compared with statements followed by non-normative evidence. And this effect was mediated by how convincing the evidence was perceived. Therefore, to change a belief, one should provide normative evidence. So seeing the strong impact of social normativity cues on belief change made us wonder if the source of the normativity cue also mattered in determining how beliefs can change. So we tested whether large groups of people, individual people, experts, or political leaders would be more effective at changing people's beliefs. Participants rated a set of statements after which they were shown how much other people believed these statements in 10 between subject conditions. We had a control condition with no additional information. We had 3 groups of prior participants, either non-specific or denoted as Democrats or Republicans, a health expert, an anecdote, or a political leader. Then participants rated again the believability of the initial statements. And here I'm plotting the change in knowledge on the x-axis as a function of these 10 conditions on the y. And higher knowledge means an increase in belief in true information, but also a decrease in belief in false information. And here we find that compared to the control condition, participants increased their knowledge more when evidence was presented by a nondescript group of prior participants. We did not find any source interaction with participants' political affiliation, suggesting that Democrats and Republicans were similarly affected by information sources. In ongoing work, we're exploring the mechanisms driving these findings. So in summary, at the individual level, I described several ways in which beliefs can be changed that complement the rational model of belief update. For instance, belief endorsement can be changed by manipulating mnemonic accessibility, triggering prediction errors, or making normativity cues salient. So the next step in the social interactionist approach is exploring how such effects occur in dyadic contexts. So at this level, we build on the literature on social influence, showing how thinking is socially constructed, leading to an alignment between interacting individuals. We wanted to see how desynchronization might shape belief change. And to investigate, we asked participants to rate a set of statements, after which we paired them in groups of 2 and instructed them to discuss the statements. Lastly, we asked participants to rate the statements again at post-test. And here on the x-axis, I'll plot how much the conversational partner endorsed or opposed each statement in the conversation. And on the y-axis, how much the participants changed their beliefs to match what the partner had said. The results showed that participants were very sensitive to their conversational partners and increased their beliefs in the statements their partners endorsed, while decreasing their beliefs in the statements their partners refuted. This pattern was strongest for initially moderately held beliefs depicted here in yellow. The takeaway of this study being that individuals are sensitive to their conversational partners. So finally, to investigate how individual cognitive effects propagate in social networks, we picked the memory impact on beliefs that I described in study 1. And our paradigm at the collective level mimicked scenarios in which individuals first listen to a public speaker that reiterates some of their beliefs, and then communicate with one another within their social networks about those beliefs. To investigate the collective belief dynamic of a group of people who encounter such a situation, we invite participants into the lab in groups of 12 to form a lab-created social network. Participants first evaluated the believability of a set of health beliefs organized across categories, after which some of the social networks listened to a public speaker selectively mentioning a subset of the previously evaluated beliefs in the practice condition, while the control networks filled out a distracted task. And then all participants engaged in conversational interactions within their social networks, following the temporally unfolding conversational network structure depicted here in 4 rounds, with each link between participants depicting a dyadic interaction. So here we created a network that mimics the main characteristics of real-world social networks: clustered communities characterized by frequent within-cluster interactions. And lastly, participants rated the statements again and then a 3rd time after 1 week. We recruited a sample of 168 Princeton students to form 14 12-member communities, and found that participants in the practice networks synchronized their beliefs with each other more than participants in the control networks by increasing their practiced beliefs here in orange, but also by decreasing their unpracticed beliefs here in blue. The finding that mnemonic accessibility increases collective belief synchronization made us wonder to what degree the network structure that people were embedded in mattered in how this collective belief formed. So to investigate, participants in another study rated the accuracy of a set of health statements, after which they were exposed to evidence either in favor or against these initial statements, and were then directed to the conversational interaction phase, in which they had conversations with other participants in their networks, following a temporally unfolding conversational network structure in 5 rounds. Lastly, participants rated the statements again. I recruited a sample of 140 Princeton students to form 14 10-member communities, and to test whether the structure of the network influenced the degree of synchronization, we first constructed a hypothesis matrix representing each network structure by mapping for each pair of participants in the network their distance from each other in degrees of separation. We then computed the empirical data matrix, which contained the changing correlations of beliefs for each pair of participants, and ran a non-parametric statistical test, or a bootstrap, to assess whether the empirical matrices were better explained by the true network structure than by any other randomized network structure of equivalent constraints that we simulated, and indeed found support for these hypotheses, meaning that belief synchronization was determined by the structure of the network that the individuals were embedded in. In summary, this research program can issue a series of empirically driven recommendations for policymakers interested in changing beliefs in a targeted fashion. For instance, the strategy of increasing mnemonic accessibility works best on strongly endorsed beliefs. But different strategies worked better at different levels of initial endorsement. For instance, a strategy that I didn't discuss here, but involves increasing emotional arousal, is most effective in the case of initially strongly opposed beliefs. And revealing the source worked best on the case of moderately endorsed beliefs. So taking all of these findings together, to change a belief that is strongly endorsed, one could either increase its mnemonic accessibility or trigger large prediction errors. However, if that belief is only moderately endorsed, the options are to decrease its accessibility, reveal the information source, or trigger large prediction errors. And if the belief is initially strongly opposed, one could either associate it with emotional images, emphasize social norms, or trigger large prediction errors. And if one engages in either of these strategies at the level of the community, one could expect people's beliefs to change to align with each other, conversations to amplify individual processes, and people's beliefs to change according to their network structure. So now let me give you a brief flavor of some current research directions I'm excited about. First, I'm interested in understanding the psychological drivers of climate beliefs and climate action. This research stems from the newest reports by the UN warning that wildfires, floods, drought, and rising sea levels will become more and more frequent, with new projections showing that as increasing parts of the world become uninhabitable, the displacements of billions of people will create a refugee crisis that could lead to worldwide economic collapse. Unless, of course, we engage in coordinated global action. So in my current work, I'm applying sociocognitive strategies to stimulate collective climate action. In an ongoing international collaboration, I'm comparing the state-of-the-art collective climate action interventions in a randomized controlled trial conducted in over 80 countries around the world. In this experiment, we're testing both individual level climate action, for example, tree planting efforts, as well as collective climate action, such as supporting climate policy. And these are the 11 interventions we're testing, which we chose and designed with input from our over 200 collaborators. And these are their projected relative effectiveness as rated by our collaborators. So we look forward to these results and to compare these predictions with the actual results of the interventions. So stay tuned for these findings projected to be collected by the end of this year. In current work, I'm also interested in the role of artificial intelligence in shaping our worldview beliefs. And this research trajectory was motivated by the numerous instances of algorithmic oppression recently uncovered, ranging from hiring to university admissions, the criminal sentencing, and healthcare allocation, to name a few. But what causes such biases? A common assumption is that they reflect existing disparities existing in society, represented in the data on which these algorithms are trained. However, if this is the case, there's a risk that their outputs could propagate these existing biases back into society, thereby creating this reinforcing bias of inequality. This perspective suggests that AI decision tools could potentially contribute to a cycle of perpetuating inequality. To investigate this hypothesis, we first assess the relationship between existing societal inequality and algorithmic search output inequality in the context of gender in two multinational studies. We first tested the hypothesis that the degree of gender inequality within a society would predict a pattern of algorithmic gender inequality in internet search outputs. And to investigate, we obtained an open source data set known as the Global Gender Gap Index, computed by the World Economic Forum, containing rankings of gender inequality for each country in the world. And to develop an assessment of gender bias in algorithmic output, we drew upon classic research on the prototype bias, by which words such as person, student, or human are more often assumed to be a man. Indeed, recent research with using natural language processing to analyze billions of words on the internet also showed that the concept of person is more similar to that of men than to that of woman. And online algorithms designed to translate make gender biased errors, assigning a masculine gender to professions such as doctor, despite the original sentence implying a woman. Based on this research, we developed an approach which involved conducting Google image searches for the keyword person in each country using a VPN and computing a gender bias score for each country using the ratio of men to women results in the first 100 images. Using this approach, we collected data in over 50 countries. And to assess our central hypotheses, we tested the relation between the global gender gap on the x-axis and the degree of gender disparity in these image outputs on the y-axis. And this effect was highly significant, such that the proportion of male images was higher in nations with greater inequality, in an initial sample of 37 countries and a replication of 52 countries. Therefore, studies 1 and 2 provide empirical evidence that societal level gender disparities are reflected in algorithmic outputs. Having demonstrated this association between gender inequality and algorithmic output, we turn to our next question: whether exposure to such algorithmic outputs can shape people's cognitive concept and decisions in manners consistent with this pre-existing inequality, thereby completing the cycle of bias propagation. To investigate, we recruited a sample of US participants and presented them with images depicting the Google image search results of new professions. And the gender composition of these professions was manipulated to display gender ratios of high inequality nations, for example, approximately 90% men in Hungary or Turkey, or low gender inequality nations with 50-50 men to women in Iceland or Finland. The procedure was the following. First, participants made prototypicality judgments regarding a new profession. For example, they were asked, who's more likely to be a perker, a man or a woman? And then participants were told they would be able to see the Google image search results for these professions. And we randomly assigned the professions to appear in either the high or the low inequality condition. As you can see here, in the high inequality condition, we showed mostly men building wigs. And in a low inequality condition, we showed a ratio of 1-to-1 men to women building wigs. And then we asked participants again, the prototypicality question, after which they were faced with a forced choice decision task, in which they had to choose between two applicants for a job in each of the professions that they learned about. Here are the results plotted as the low and high inequality conditions against the proportion of women chosen in the task. And the 50% dotted line represents no gender bias. At pretest, participants thought men were more likely to perform the new professions. And this replicates the male default bias. At post-test, however, prototype ratings became more egalitarian in the low compared to the high inequality condition. Indeed, exposure to search results pattern found in the low inequality nations reversed participants' male biased prototypes, whereas exposure to search results patterns found in the high inequality nations appeared to reinforce and maintain this prototype. Exposure to image sets in the low inequality condition also produce a higher likelihood of choosing women as the job candidates. And in a mediation analysis, our overarching prediction was supported. Exposure to high versus low inequality search results shaped gender prototype formation, which in turn influenced gender-biased hiring. In conclusion, in two sets of cross-national studies, we provide empirical evidence that societal inequality is reflected in algorithmic inequality, and that algorithmic inequality influences decisions aligning with this inequality, further reinforcing the pattern of discrimination in a self-perpetuating cycle of bias propagation. These findings suggest that new intervention points for bias reduction may involve uncovering how human decision makers interact with algorithmic outputs. Together, these research directions aspire to advance our understanding of some of the critical challenges facing our society, growing inequality, and the climate crisis. And my new lab at NYU will continue focusing on these two applications of collective cognitive processes. And with that, I would like to thank my collaborators, my funding sources, and more importantly, all of you for listening. And I'm looking forward to your questions. So please email me if you would like to further discuss. Hi, thank you for coming to my talk.